Okay. So we are going to start October-November 2022 paper 4-2 today. Question number 1. Just give me a minute, please. Okay. So let's start with question number 1. In question number 1, calcium chloride is an ionic solid. Okay. In the first part, if you look, they have asked you to define the lattice energy. So that it is the energy change when 1 mole of an ionic solid is formed from the data in table 1.1. Calculate the standard enthalpy change of formation of calcium chloride. So if you remember, right, so here there is no need of a data booklet. Whatever we have already provided in the table along with the question. Otherwise, there are 2 pages at the end of the paper. In one page there are the constant values are given, and on the other page there is a product table. So beside this paper, you don't need anything. Okay. So we have to find the enthalpy change of formation. It may be helpful to draw an energy cycle. Show all your working. So, which is calcium chloride, right? And its formula is CaCl2. Okay. Formula is CaCl2. If you see in this calcium chloride, we have 1 mole of calcium, 2 positive ions, and 2 moles of chloride ions, right? So if there are 2 moles of chloride ion, so if any energy change which is given or provided over here with respect to 1 mole of chlorine, we have to multiply it with 2. That you have to keep in mind. Okay, so if I will write the expression for the enthalpy change of formation of calcium chloride. So the enthalpy change of formation of calcium chloride just give me a minute. Okay, So it is actually equals to the lattice energy of calcium chloride, right? Then atomization of calcium. Then, if you recall, calcium is actually a 2 positive ion. So first ionization energy of calcium, then second ionization energy of calcium, then atomization of chlorine. But as there are 2 moles of chlorine, so actually I need twice of the atomization of chlorine. Okay. So twice of the atomization of chlorine, and then chlorine is turning into minus 1 ion. So, and there are 2 chloride ions, so twice of the electron affinity of chlorine. Is this clear to everyone till here?
Yes, sir.
Okay. Now let's look at the table and then substitute the values in the expression. Okay. So this is the lattice energy. So I would write over here minus 2237, then plus what is next? Next I have a atomization of calcium. So this is the atomization of calcium, right? Positive 193. So 193 over here. Then first and the second ionization energies of calcium. So this one is the first ionization energy of calcium, and this one is the second ionization energy of calcium. So 590 plus 1150. Then I need the twice of the atomization of chlorine. And here they have provided you the atomization of chlorine, which is kilojoule per mole. So as it's a atomization of chlorine, so I have to make it times 2. So I would put 2 times 121. Then there is a first electron affinity of chlorine. So I have to make this value as times 2 as well. So 2 times minus 364. So we put all the values. And now what we have to do, we have just to put in the calculator and then get the answer. So can anybody tell me the answer?
Sir, minus 790, sir.
Sorry. Minus
790, sir.
minus 790 kilojoule per mole. Okay. So I would write over here minus 790. Is this understandable to everyone? Okay. Now in the next part, 3 possible values for the first electron affinity of bromine are shown in table 1.2. One of them is correct. Place a tick by correct value, explain your answer. Okay. If you look in the periodic table, and specifically at group 7, you would find then we have a first fluorine, then we have a chlorine, then we have a bromine, then we have an iodine, then we have an astatine. So here I'm going to write the electron affinity of a chlorine, which is provided over here, and the electron affinity of a chlorine is minus 364, right? So it's minus 364. And if we look at a chlorine atom, if it's of this much size, then the bromine, must be the bigger. And if bromine must be the bigger than the chlorine, then when it attracts the electron, it attracts the electron with a lesser force, right? So if it attracts the electron with a lesser force, so which means that so it is wrong. It is greater than chlorine, so it is also wrong. So it means this one is the correct because here the lesser amount of energy is being released. So I would put a tick over here, and the explanation over here would be that bromine is bigger in size than chlorine. Yes, is this understandable to everyone?
Yes, sir.
Okay. The D part. The enthalpy change of hydration of chloride ion can be calculated using the lattice energy of calcium chloride and the data shown. Okay. So the enthalpy change of hydration for chlorine is needed to be calculated, and the lattice energy for calcium chloride is actually provided over here. If you see here, it is minus 2237 kilojoule per mole. What else they have provided to you? That there is a enthalpy change of solution of calcium chloride and yes, am I audible? Yes, am I audible now?
Yes, sir.
Okay, okay. So it is the enthalpy change when 1 mole of a substance, or you can write 1 mole of ionic solid. Sorry, 1 mole of solute dissolves in water to form very dilute solution. Then we have an enthalpy change of hydration. So I can write that it is the enthalpy change when 1 mole of specific gaseous ion dissolve in water to form very dilute solution. Yes. Is this understandable to everyone?
Yes, sir.
Of chloride ion, it may be helpful to draw an energy cycle, show all your working. Okay, so we have to show all the working over here. So it's very easy. See, for example, if I have a calcium gaseous ion and I have a 2 moles of chloride gaseous ions, and in a one reaction they are turning into 1 mole of calcium chloride solid, then I will call this lattice energy. Then, for example, if you dissolve this 1 mole ionic compound in water, as a result we get the aqueous ions. So it would considered as the enthalpy change of a solution of calcium chloride. Then when the calcium gaseous ion and the chloride gaseous ions get dissolved to form the aqueous ions, in this case we can represent this reaction of this arrow by enthalpy change of hydration of calcium ions plus twice of enthalpy change of hydration of chloride ions. Is this understandable to everyone?
Yes, sir.
Okay. Now, let's put these values. So see, the lattice energy of here, I would put minus 2237. Then the enthalpy change of calcium chloride is minus 83. So I would put over here minus 83. Yes.
सर एनर्जी साइकिल से बेहतर नहीं है फॉर्मूला इस्तेमाल कर ले छोटा भी होगा शॉर्ट
Yes, you can. If you remember the formula, then you can use it. Otherwise, this is the safest way.
ओके सर ओके
Otherwise, you can just use the formula as well. So the hydration of a calcium chloride is over here minus 1650, and we have to find the enthalpy change of hydration of chloride, and here we have a 2 moles. So I would label it or equate it with a 2x. Is this clear? Now, then you can easily predict that here, this is your starting point, and this is your direct route, and from Just 1 minute, please. Is my screen is shared now? Yes?
Yes, sir.
Okay. So direct root is equals to indirect root. So here I can write the equation minus 1650 plus 2x is equals to minus 2237 plus minus 83. So plus minus 83 and plus 1650 divided by 2. Right? So can anybody solve and tell
So
me the
negative
answer?
335.
So it is negative 335. Okay. Now, next part. Calcium fluoride can be synthesized directly from its elements. Right? Okay. So the value of the enthalpy change of formation of calcium fluoride is minus 1214. Predict the sign of the entropy change for this synthesis. Explain your answer. Okay. So it means they are talking about this reaction where there is a solid calcium and fluorine. We know it exists as a gas in the at the room temperature, would be forming calcium fluoride solid. So what would be the change in entropy? Is it a positive or a negative?
Negative.
Yeah, good. It's a negative one because why?
Gas is being converted into
Yes, who can
solid.
yes, good. So I can write that the number of moles of gas are decreased. Basically, these number of moles of gas are decreased. That's why it is considered as a negative. Is this clear to everyone?
Yes, sir.
Okay. Now, use the value of delta HF formation of calcium fluoride given in E and your answer to E1, okay, to predict how the feasibility of this reaction synthesis will change with increasing the temperature. Okay, so for that you have to look at this expression that gives free energy changes to here is a negative value. The entropy change is also a negative value. And what we are doing, we are increasing the temperature. So if I'm increasing the temperature, so what would happen that and negative T delta S is positive. So the change in Gibbs free energy will actually be positive. So the reaction becomes less feasible. Is this understandable? So I can write that T delta S gets more negative and more positive on increasing temperature, change in Gibbs free energy would become positive. So reaction gets less feasible, or its feasibility decreases.
Sir,
Yes. Is this part is understandable to everyone? Can you repeat, beta? Can you repeat again?
आप part 1 समझा.
One minute. Okay. You're asking for this part one? Yes,
Yes, sir.
Soleha? So in part one, basically, if you see our product, our reactant is a fluorine, which is in a gaseous state. So when the reaction occurs, that all of the calcium is going to consume, and as a, so what highest entropy values, because the particles are moving randomly. So if the gas is disappearing and turning into a solid, so in solid the particles are more uniformly arranged, so the entropy of the solid would be lower, so the change in entropy would be negative. Is it clear now?
Yes, sir. Thank you.
Okay. Now,
सर ये
yes.
जो ऊपर सवाल किया है उसका गिव्स फ्री एनर्जी वाला, तो सर हमें कैसे ब्लू वाले टेम्परेचर बढ़ाया है तो टेम्परेचर जो पॉजिटिव हो रहा है, क्या बताओ -20 से -20 हो रहा है, तो फिर भी वो तो गिव्स फ्री एनर्जी माइनस में ही आएगी ना.
Listen.
जी सर.
Yes, Gibbs energy comes in the negative, the way you are saying. But the thing is that its value is decreasing, its value is getting closer to the positive.
Yes sir.
So agar if it's become getting closer to the positive, so what happens to the feasibility? The feasibility would become lesser than the previous one.
ठीक है सर, समझ गया.
Okay, now we are going to start question number 2. Here in question number 2, nitrogen monoxide reacts with ozone. Okay, the reaction is first order with respect to both NO and ozone. At 298 Kelvin, the rate constant K is 11,500 mole inverse dm cube, and second inverse. Okay, complete the rate equation for this reaction. So as they have provided us that it is first order with both the reactants, so I would write rate is equals to K, which is rate constant, times concentration of NO2 raised to the power 1 because its order is first, then times concentration of ozone also raised to the power 1 because its order is first. Is this understandable to everyone?
Sir, it's NO, not NO2.
Oh yeah, it's NO. Sorry, thank you, Rafael. So the concentration of NO raised to the power 1 and concentration of ozone raised to the power 1, because both are with respect to both of the reactants, it's first order, so we keep the power 1 only. Is this clear?
Yes, sir.
Yes. Okay. Then in question number 2, a reaction is carried out in which the initial concentration of NO and ozone are both 1.2 exponent minus 6 mole per dm cube. Okay. Calculate the initial rate of the reaction, state its unit. Yes. How could we do this? Yes. Can anyone suggest how to attempt this part?
वाले में रेट कांस्टेंट दिया हुआ है तो उसको यूज करेंगे दोनों की ये वाली कंसंट्रेशन उसके अंदर रखें और फिर रेट कैलकुलेट करेंगे.
Yeah, very good. Because here we have the rate equation and we got the rate constant as well. And we have to find the rate of reaction. So I would use the rate expression over here, that rate is equals to rate constant K times concentration of NO times concentration of ozone. So rate is actually equals to rate constant, which is 11,500 times concentration of NO, that is 1.20 exponent minus 6 times concentration of ozone, which is also equals to 1.20 exponent minus 6. So put it in the calculator and solve it and tell me the answer.
Sir, 1.656 exponent minus 8.
1.656
exponent minus 8.
exponent minus 8. So when I'm going to put it into three significant figures, so it would become 1.66 exponent minus 8. Now I have to find the unit. So if you see, the unit of rate constant is actually dm cube over mole over second times concentration of NO mole per dm cube times concentration of ozone mole per dm cube. So these mole and dm cube are actually cancelled out, and we are left with mole per dm cube per second. That is also the actually the unit of rate as well. Is this clear?
Yes, sir.
Okay. Now, the reaction described in A2 is monitored over a period of time. Okay. Predict whether or not the graph of NO against time, the graph of concentration of NO against time under these conditions show that the reaction has a constant half-life. Explain your answer. The reaction
मैंने तभी कांस्टेंट होगी इसकी हाफ लाइफ.
no. The reaction is carried out in which the initial concentration of both NO and NO3 O3 are both the same. No, it's not constant. Now listen this part very carefully, okay? This is the important thing. The order with respect to the NO is what?
First,
Yes, first. And the order with respect to ozone is also
first,
first. Now think, for example, if the initial concentration uh, 1 minute. Okay, let me make the table somewhere over here. Okay, think. I have a experiment 1. Here I have a concentration of NO, and here I have the concentration of oxygen, and here I have a rate. For example, the initial concentration of oxygen is 5. And here let's suppose they are saying what we are monitoring. We are reaction described in 8. Okay, now am I audible?
Yes, sir.
Okay. Just give me a minute, please.